Alright, this is number 35 on page 229, and it's a factoring and simplify problem. I have to simplify this rational expression, and I'm going to have to factor to do that. And this one's kind of a doozy. It's got a lot in it. It's reasonably sophisticated. So let's just break up the numerator and denominator into two separate parts and factor each of them individually, and then we'll put it back together at the end and look for common factors, some ones and negative ones. So anyway, I notice in the numerator, we'll start there with the numerator. I've got 4 terms, 1, 2, 3, 4, and so that tells me I'm going to try and see if I can factor this by grouping, because that indeed does work. So if I pull out the greatest common factor between the first 2 terms, that's an x to the third, and that would factor out an x plus a y. And then when I look at the second 2 terms, I can pull out a y to the third, and if I make that a negative y to the third, I can put the x plus y in here. So this would be my negative xy to the third and my minus y to the fourth right here. So that all works. And then factoring by grouping, I'm looking this is a difference between this product and this product, and I can pull out the greatest common factor, which is the x plus y, and I'm left with x to the third minus y to the third. So if you FOIL this back, you'll get the original 4 terms in that polynomial up there. Now the thing is that you're not done right there, because this right here is a sum of 2 cubes. Oh, I'm sorry, it's a difference of 2 cubes. Difference of 2 cubes. So when I look at that and frame it as a difference of 2 cubes, the a is the x and the b in the pattern is the y. So I'll still have this original, this x plus y factor right here, and then x to the third minus y to the third is a binomial times a trinomial, and this is x, y, x squared, x, y squared, and it's a difference, so this is the same, opposite, and always positive. So that's the numerator as factored out as I can get it, because we know we can't do anything more with this trinomial, and these are both linear x's and y's. So now let's take a look at the denominator and factor that out. So the denominator is x to the fourth minus y to the fourth, and that is a difference of 2 squares, because this is x squared squared, and this is y squared squared. So this is going to factor to the sum and difference pattern. So x squared plus y squared times x squared minus y squared, and you can multiply this back and you'll get this. So one of these breaks down further. The sum of the 2 squares doesn't, but this difference of 2 squares breaks down. So I'm still going to have the sum of the 2 squares, x squared plus y squared, and then x squared minus y squared, by now you should be pretty familiar with this, breaks down to x plus y times x minus y. So that's as factored as I can get. There's nothing more I can do with the sum of 2 squares, and these are both linear x's and y's. So now when I go back and I put the numerator, which is factored, looks like this, over the denominator, which is right here, fully factored, those ones that we're going to cancel are fairly glaring now. So we have a 1 in the form of x plus y over x plus y, and another 1 in the form of x minus y over x minus y. So final answer that we're left with is simplified as can be. It's x squared plus xy plus y squared in the numerator, all over x squared plus y squared. So that's page 229, number 35, and that is a good problem. It's got a lot in it. That's it.